if you like, a fake make-believe pop quiz. Here's what I would like you to do without consulting any deep learning notes. Tell me, what's the cosine of a plus b, the sine of a plus b, and the tangent of a plus b? Try to fill those out from memory, if you will. Again, that does mean you do have to have the notes out because that's what this is. So much people deep in on what formula is actually writing down. And I'm not collecting this or anything. So as folks trickle in, I have decided to start today with a pop quiz. I would like you to tell me, what are the cosine of a plus b, sine of a plus b, and tangent of a plus b equal to? Ideally, in this part in your notes, I just want you to do it that way, just looking back. I should go and see if we can tease out the memory. All right, let's come together. What's the cosine of a plus b? Yeah.
That'll be a cosine a sine of it, or right, sine plus cosine b times sine b.
Not quite. Yeah.
Cosine A times cosine B minus cosine A, or sine A, sine B.
Yeah. Oh, that should be a b. You said b. Nice. So let's see, maybe by a show of hands, how many people had that without looking deeper in their notes? Nice. All right, same thing for sine. What's the sine of a plus b? Yeah.
Is it cosine A times sine B plus sine A and times cosine B?
Yes. What you said is right, but you notice I wrote it in the opposite order. The reason I wrote it in the opposite order, it doesn't matter what order you add things in, so it's correct. But with it in that order, you get the right thing when you subtract. Groovy. How about tangent? What's the tangent of a plus b? Cool.
Well, another for the
Tangent A plus tangent B over 1 minus tangent A times tangent B.
Yeah. All right, so let's see. By a show of hands, without consulting your notes, how many people aced that fake pop quiz? How many people got a passing grade on that fake pop quiz? All right, cool. And again, these are things that I expect you to have internalized at this point. And in fact, on the assessments from here on out, you're allowed a note sheet. You might want to have those formulas on them. Cool. So here's the point. Yeah.
for the assessment, do we have to return the note sheet, or do we still have to keep?
On the final exam, I will absolutely not let you keep it under any circumstance.
Okay,
If you do want to keep that note sheet, just make 2 of it.
cool,
Or make 1 of it and then photocopy it or something.
cool.
On the midterm, I'll allow the thing where I like look at the note sheet and say, yeah, this looks clean, and then let you keep it.
Okay.
Groovy. So, let's see. Those are the formula that tells what to do whenever you add 2 things together. Well, there's one interesting instance of adding 2 things together, and that's multiplying a thing by 2. Multiplying a thing by 2 is adding a thing to itself. Out of that, we can get some double angle formulas. And while we did hit those last time, I think I want to hit them again real quick. So if you want the cosine of 2 theta, that is apparently cosine of theta times cosine of theta, also known as the square of the cosine of theta, minus the square of the sine of theta. Sine of 2 theta is sine theta cosine theta plus cosine theta sine theta. Folks feel pretty good about this so far? And you can do the same for tangent. If you want the tangent of 2 times theta, well, that's tangent of theta plus theta. So that'll be tan theta plus tan theta, 2 tan theta, all over 1 minus tan theta tan theta. Groovy. And we did hit those last time, but hopefully it's nice seeing them again. Maybe I'll also remind you that there are 2 other double angle formulas for cosine. And each of them are given by the fact that if you look in this formula, I see a cosine squared and a sine squared. You never need to see a cosine squared and a sine squared. You can use the Pythagorean identity to replace sine squared by 1 minus cosine squared. If you do that and you simplify, you'll see that the cosine of 2 theta is equal to 2 times the cosine squared of theta minus 1. So there's one of them. The other one says that the cosine of 2 theta is the same thing as 1 minus 2 times the sine squared of theta. Groovy. Folks feel pretty okay right now? So there's not going to be more of these notes that I can fit in the owl. So I'll see, well, no, I think this is the example that just supposed to be done. Let's use these to compute some things. So let's suppose I give you an angle theta, and I'm not telling you what the angle is, but I am telling you that sine of this angle is 3/5, and that this angle is somewhere between pi over 2 and pi. Let's use that to determine everything about 2 times theta. So let's proceed. Well, if I only know sine of theta, is there a formula that I can use to detect cosine of 2 theta if I only know sine of theta? Ooh, that's an interesting noise. Was that you?
Yeah, I got an email, sorry.
Okay. Give me a real quick page. Yeah, so we can use that formula. Cosine of 2 theta is 1 minus sine squared of theta. 1 minus 2 times sine squared of theta. Cool. And do I already know what the sine of theta is? Is that a given? Well, that is. That's why I chose this one. It is a given in the problem. What is the sine of theta in this problem? 3/5. So let's plug in 3/5 for sine. This will become 1 minus 3 over 5 squared. Oh, neat. There's no more trigonometry left in this problem. Let's just simplify that number. Gosh, I guess 3/5 is 9/25.
Yeah.
Did I lose a 2? Okay, I'm gonna put that 2 back. When I do something wrong, you don't just have to look at me like I'm an idiot. You can also tell me what I did wrong. I managed to read your facial expressions correctly this time. So let's do it. So 3 over 5 squared becomes 9 over 25. So we actually write the 1 as 25 over 25 to make the subtraction easier. This will become 25 25ths. That's the 1. Minus 2 times 9 is 18 over 25. So far, so good? Ali, what's the question?
I'm just double checking the work that's not, so you don't miss something.
Ah, okay. 25 minus 18 is 7, right? Cool. So it looks like this works out to be 7 25ths. Cool. Do we have a double angle formula for sine that we could use? Yeah, let's write it down. The sine of 2 theta is the same as 2 times sine theta cosine theta. Do I already know what sine of theta is?
Yeah, just give them
3
3 times.
fifths. Do I already know what cosine of theta is?
So,
Not cosine of 2 theta. Do I already know what cosine of theta is? Does anyone in this room already know what the cosine of theta is? Yeah.
wouldn't that just be 4 over 5?
I hear 4 over 5. Do you want to hear any others? You're almost right.
Oh, we already got the quadrant.
What quadrant is this angle in?
2.
Quadrant 2. So will cosine be positive or negative?
Negative.
So I think it's going to work out to be negative 4 fifths. Should I go through the walk of computing cosine given sine? Do people want to see that? Cool, let's do it. So here's the general rule. If you know sine, because we do know sine of theta is 3 fifths. If you want to compute cosine of theta, the rule to use is sine squared theta plus cosine squared theta is always equal to 1. And let's now just go through the motions. So I know sine, so I can plug in what I know about sine. 3 fifths squared plus, I'll do my standard thing where I don't want to write cosine so many times, so I'll replace that with a c, equals 1. And now I need to solve that for c. And maybe I'll do a few things all in one step. What's 3 over 5 quantity squared? 9 over 25. I need to subtract that to the other side. So I'll rewrite the 1 as 25 over 25 and then subtract. So c squared is 25 over 25, because that's 1, minus 9 over 25, because that's 3 over 5 squared. So what is c squared equal to?
16 over 25.
16 over 25. So I need to take the square root of both sides. I get a plus or minus. Should it be plus or should it be minus? Minus, because of this quadrant thing. And are there any perfect squares underneath that square root?
Yes.
What's the square root of 16 25ths?
4 over 5.
4 over 5. Nice. So negative 4 fifths. Hopefully that felt pretty familiar to everyone. Like a computation we've done a few times now. Nice. So now that I know what goes here, 2 sine theta cosine theta is 2. 2. Sine theta is 3 fifths. Cosine theta is negative 4 fifths. 2 times 3, gosh, maybe this 12 times 2, 24, negative 24 over 25?
Yeah.
All right. All right, there's the sine of 2 theta. Finally, we want to compute the tangent of 2 theta. So in looking at this, don't try to do it all at once. What strategy would you want to follow to compute tangent of 2 theta in this situation? Yeah.
Well, I think it'll be better to first find what tangent is, and then if we know like what tangent is, we can plug it into the equation of one out of it.
Yeah, sure. Let's start by, I know cosine of theta is negative 4/5. So here's one strategy to compute tangent of 2 theta. Compute tangent of theta as sine theta over cosine theta. Then I can use the double angle formula for tangent. There's one strategy. Does someone see another strategy? Do I already know sine of 2 theta? Do I already know cosine of 2 theta?
Oh, yeah.
So I could just divide those. Which one seems like less effort in this circumstance?
The second one.
The second one? So let's do the second one, then we'll do the other one if people want to see. So tangent of 2 theta. What you said wasn't wrong. It would just take like maybe longer.
Oh, yeah.
In the time I took stalling, instead I could have just done your strategy. So tangent of 2 theta is the same as sine of 2 theta over cosine 2 theta. What's the sine of 2 theta?
Negative 24 over 25.
What's the cosine of 2 theta?
7 over 25.
7 over 25. Does anything cancel?
Doesn't the 25 cancel out?
Yep. Divide the numerator and denominator by 25 will undo, resulting in just negative 24 over 7. Cool. People feel pretty good about double angles right now? Any questions so far? So I'd like to, so here's the main topic of today that I'm going to spend the rest of the time on, is half angles. If we know how to double an angle, surely we can figure out how to divide an angle by 2. So that's just like doing the opposite. And here's a strategy I'll use to get a half angle formula. So cosine of theta, well that's certainly the same thing as the cosine of 2 times theta over 2, right?
Yeah.
You divide something by 2 and then multiply it by 2. I'm going to add some colored parentheses for emphasis here. Let's try to work out what this simplifies to. So in the thing that's written right there, do you see cosine of 2 times a number? So here's what I'm going to do. I'm going to try to use the double angle identity to get an expression, and then I'll see if I can simplify. So the double angle formula says that the cosine of 2 times theta over 2 should be the same thing as 2 times cosine squared, and then the thing that's getting multiplied by 2, minus 1. People feel okay right now? But I haven't done much. I just used the double angle formula. Here's the key observation. Cosine theta equals 2 cosine squared of theta over 2 minus 1. Those two things are set equal to each other. Does that look like an equation that I could conceivably solve for cosine of theta over 2? Yeah. It's even like reasonably straightforward. Add 1 to the other side. Divide the 2 to the other side. Take square root of both sides, and I guess you're done. So, going through those motions in the time that I took stalling, some of you are probably already writing it down, but I'll go write it down. So, add 1 and divide by 2. Let's do that first. So apparently cosine of theta plus 1 all over 2 is cosine squared theta over 2. And now if I want just the cosine of theta over 2, I guess I have to take a square root. So I'll do that. And I'll do it in a slightly wrong way. And then you'll tell me what the wrong thing I've done was. So this is slightly wrong. Cosine theta over 2 is the square root of cosine theta plus 1 all over 2. What have I done wrong? Yeah.
Plus or minus.
All right, whenever you undo a square with a square root, you lose information. You don't know whether the result is positive or negative, so you just need to put that in. All right, so here's the thing that we've written down that presumably is true. In order to see if it's true, maybe it's worth like graphing it. So let's graph this, and see if the graphs are like the same. So keep those in your head. I guess I don't even need to have you do that. They're right there. The cosine of x over 2, that's what the independent variable should be called in Desmos, and the square root of cosine of x plus 1, close parentheses, divide by 2. Let's make that dashed. All right, the dotted black graph and the green graph, do they look like they're the exact same? Are they at worst off by a plus or minus sign? Yeah. It looks like sometimes black is exactly green, and over here it looks like black is negative green. Cool. So I think I believe the formula. Do you think we could get similar things for the other trig functions too? Yeah, right. If you can do tangent, if you can do cosine, then you can do sine. If you can do cosine and sine, you can definitely do tangent. I haven't even mentioned secant, cosecant, or cotangent, but that's because if you can do things for sine, cosine, and tangent, you can do things for their reciprocals also. So let's do that. So let's write these down. So the cosine of theta over 2 is plus or minus the square root of, I'm going to take what's written exactly there, but I'm going to put the 1 before the cosine. It doesn't make a difference, but it'll make the half-angle formula for sine look more natural. 1 plus cosine of theta all over 2, big square root. Sine of theta over 2 is plus or minus the square root of 1 minus cosine theta all over 2. Tangent of theta over 2 is plus or minus the square root of 1 minus cosine of theta all over 1 plus cosine theta. Cool. So how many people, when looking at those formulas, look at them and think, well, that's weird. The half-angle formula for sine of theta depends on cosine of theta instead of sine of theta? That's a fair response. It is weird. And we'll hit the reason for that by the end of today. In the meantime, I'm going to take those formulas, I'm going to put them on the board, and then we'll use them to do some stuff. All right, they're there. So let's use these to make some computations. And let's start with one that has been a computation I've alluded to for a while now that we haven't actually done. Now we can. Let's try to compute the cosine of pi over 8. And we've said what the cosine of pi over 8 is a few times. How many people just remember what we said the cosine of pi over 8 is? for people if they were just willing to hazard a guess that had no negative repercussions if it was yeah.
Is it the square root of 2 plus the square root of 2 over 2?
Something like that. Let's find out by computing it. Let's try to compute the cosine of pi over 8. Here's the strategy. Is pi over 8 half of an angle that we do understand well? Yeah, it's half of pi over 4. So let's use this. Cosine of pi over 8 is cosine of pi over 4, which I'll emphasize in orange, over 2. And we have a formula now. Cosine of thing divided by 2 is plus or minus 1 plus cosine of thing divided by 2. So this will be plus or minus square root of 1 plus cosine pi over 4 all over 2. And before we make any progress, let's try to deal with the plus or minus. So we're trying to deal with an angle of pi over 8. What quadrant does pi over 8 sit in? Yeah, just say it loud. I think it's quadrant 1. And pi over 8 would be you start at 0, you rotate that by just a very little bit. Yeah, that seems like it's in quadrant 1. This is in quadrant 1. In quadrant 1, is cosine positive or negative? Positive. So cosine of pi over 8 is positive or negative? Positive. Cool. So because this is quadrant 1, that's positive. Cool. All right, so let's carry on from there. What's the cosine of pi over 4? Root 2 over 2. So this is equal to, it's plus, so I can stop writing the plus. It's plus. 1 plus root 2 over 2 all over 2. And now I guess the game is do some simplification. So in that numerator, I see 1 plus a thing divided by 2. So 1 plus a thing divided by 2, that means I should rewrite the 1 as 2 over 2 and add fractions. Let's do it. So rewrite that 1 as, no, I'm not going to rewrite it in place. I'm going to do another step. 2 over 2 plus root 2 over 2 all over 2. And the whole point of doing that is so I could add fractions. Let's add those fractions. Square root of 2 plus square root 2, close parenthesis, divide that by 2, divide that by 2. All right, so let's just read off what that says. That says start with 2, add to it the square root of 2, then divide that by 2, then divide that by 2 again, and then take the square root. What do you get if you divide something by 2 and then divide it by 2 again? Divide something? Yeah, same. Same as dividing by 4. Right? If I have something and have it again, I form it. So I could rewrite this as big square root, 2 plus the square root of 2 all over 4. Is there a perfect square under that square root I can take advantage of? What's the square root of 4? 2. So I could pull the 4 out of the square root, leaving it with 2 plus root 2 over 2. You have correctly remembered the formula. But here's the point. Now you don't need to remember that formula. You know trig functions at pi over 4, so you can figure out trig functions at pi over 8. Cool. Let's do one more where a different subtlety will appear. Let's try to compute cosine of 9 pi over 8 using the same idea. Is 9 pi over 8 half of an angle that you understand? Yeah, it's 9 pi over 4. You know how to compute trig functions at things divided by 4. Let's see what happens. cosine of 9 pi over 8 will then be, for emphasis, I'm going to color that orange, plus or minus the square root of 1 plus cosine of 9 pi over 4. There's the thing that's in orange. All that divided by 2. Cool. So let's try to work this out. And the first thing to think about will be, is it plus or is it minus? Let's try to deal with this plus or minus sign. And let's do it by thinking about this angle. 9 pi over 8. What quadrant is that in? I saw 1, 3. Let's go by 4. Quadrant 1? Quadrant 2? Quadrant 3? Quadrant 4? I don't remember how to figure out what quadrant an angle is in. Nice, let's do that. Do you remember, like, at some point doing this in the past, though? Even if you don't remember what it was? Okay. So let's try to figure it out. So here, I'll figure it out by, like, drawing a circle and thinking about what these angles are. There's an angle of 0, there's an angle of pi over 2, which I'll rewrite in a silly way, 4 pi over 4, 4 pi over 8. Here's an angle of pi, which is 8 pi over 8. Here's an angle of 3 pi over 2, also known as multiply everything set by 4, 12 pi over 8. Alright, so let's see where 9 pi over 8 fits. Is 9 pi over 8 between 0 and pi over 2? No. So if you rotate by 9 pi over 8, you'll rotate past this point. Is 9 pi over 8 between 4 pi over 8 and 8 pi over 8? No, 9 is bigger than 8. Is 9 pi over 8 between 8 pi over 8 and 12 pi over 8? Yes. 9 is bigger than 8 but less than 12. Cool. What quadrant is that in? Quadrant 3. So is cosine positive or negative? Negative. Negative. So it's quadrant 3. So this quantity is negative. All right. Next thing we need to know is the cosine of 9 pi over 4. By looking at your unit circle, what is the cosine of 9 pi over 4? I think it'll be positive. Let's talk through how to get it. So it's true that this isn't an angle you see on your unit circle. But it kind of is. Let's count up 9 pi over 4. So, here's your unit circle. See, there's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So what's the reference angle for 9 pi over 4? If you want to think of 9 pi over 4 as an angle between 0 and 2 pi, what angle would you call it? Pi over 4. So 9 pi over 4 can be the same trig functions as pi over 4. So what's the cosine of pi over 4?
Root 2 over 2.
Root 2 over 2. So what's the cosine of 9 pi over 4? Root 2 over 2. Cool. Let's carry on. This will be equal to negative, because we found that negative, the square root of 1 plus root 2 over 2, all over 2. Does that computation now look like a computation that we literally just did a minute ago? So do we need to go through it again, or are you just going to tell me what the answer is?
just equal to, yeah, whatever, what that root 2.
Yeah.
Root over 2 plus root 2 over 2.
That, but with a negative sign?
Yeah.
Cool. How do people feel so far? People feel pretty good? So I'm going to tweak the next example ever so slightly. I'm not going to try to see if this correctly predicts cosine pi over 6. I'll see if it correctly predicts sine pi over 6. In the moment, I think that feels like a more natural thing to do. Because you already know what the sine of pi over 6 is. Looking at units off of what's the sine of pi over 6? 1/2. So I already know this should be 1/2. But pi over 6 is also half of an angle that we know something about. This should be the same thing as this. Yeah. This should be the same thing as the sine of pi over 3 over 2 Do we have a formula that we can use now? Yeah. Let's use that formula. So this will be plus or minus the square root of 1 minus cosine of the thing in orange Alright, and let's start the same way we did the previous one. Let's deal with the plus or minus sign. Plus or minus. Let's see. Pi over 6. What quadrant is it in? Quadrant 1. And quadrant 1 is sine positive or negative? Positive. So should this be positive or negative?
Positive.
Cool. Because this pi over 6 is in quadrant 1. All right, so now let's carry on from there. What's the cosine of pi over 3? All right, so this is the square root of 1 minus 1/2 divided by 2. And I bet we can even do that computation without writing anything down. What's 1 minus 1/2? 1/2. What's 1/2 divided by 2? 1/4. What's the square root of 1/4? Yeah, just 1 over 2, right? Oh, square root of 1 over 2. Yeah, but what's the square root of 1? Yeah. So you have the right answer. It's all the way simplified. Cool. People feel okay about this?
Was that supposed to be sine of pi period instead of parentheses, or that's supposed to be?
It's supposed to be cosine.
Okay.
Yeah, so the half angle formula for sine has a cosine.
Okay.
Groovy. So, let's see. I think the most natural thing to do next is maybe I'll see, do you all feel like you're ready to do a computation on your own with the last couple minutes of class? So, cosine of pi over 12. Would people rather I talk through a computation? Cool. Then I will begin talking through the computation. Let's do it. Cosine of pi over 12. Is pi over 12 half of an angle that we understand already?
Yeah.
It's half of pi over 6. Oh, it's supposed to be in orange, not red. It doesn't show up differently on the projector anyway. So let's try to compute this using the half angle formula for cosine. So the half angle formula for cosine says that cosine of pi over 6 over 2 will be plus or minus the square root of 1 plus cosine of theta divided by 2. 1 plus cosine of the orange angle all over 2. Ruby, let's do it then. What's the cosine of pi over 6? Root 3 over 2. So let's replace that with that. I guess I didn't deal with the plus or minus sign. We should do that. 1 plus root 3 over 2 over 2. Let's deal with the plus or minus sign. In fact, let's just ask you about the plus or minus sign. Should it be plus or minus? Plus, because this angle is in quadrant 1. And now I guess we just have to, there's no more trigonometry to do. It's simplify this arithmetic expression. And this looks like a really similar simplification to what we did before. I see 1 plus a thing over 2. I should write the 1 as 2 over 2. And add fractions. So this will be square root of 2 over 2 plus root 3 over 2 all over 2. And you probably have a pretty good idea what's coming next, right? I see a thing divided by 2 plus a thing divided by 2, so I really see 2 plus root 3, all that divided by 2, and then all that divided by 2 again. So, I can do an intervening step if people want to see. So I'm going to get square root of 2 plus the square root of 3 all over 2. There's kind of a step skip there. Do people want to see the skip step? Yeah, okay. So, the skip step was add these fractions. So this will be the square root of 2 plus the square root of 3 over 2, then divide by 2 again. When you divide something by 2 and then divide it by 2 again, what's that the same as? Dividing by 4. What's the square root of 4? That's really stupid. Groovy. So I think the last thing I want to do in this particular note packet, so maybe I'll tell you the things that I'm going to skip in the interest of time. So we've derived the half angle formula for cosine already. If you know what cosine is, how do you find out what sine is? Yeah, just do that and solve that for sine. That'll give you the half angle formula for sine. You'll see what it is. But I think with my remaining 5 minutes, the type of things that are more likely to be assessed is more computations. So let's use these remaining 5 minutes I have to just make some computations. Let's do the thing on the next page, in fact. Let's do this. Let's try to hit some of these. So it's basically to do the computation, but what's the cosine of pi over 8 again? I don't think I want to do it again, I just want to write it down. This is like 2 pages ago, right? Oh, it's that, yeah. So we've already computed the cosine of pi over 8. It's the square root of 2 plus the square root of 2 all over 2. If we know the cosine of pi over 8, do you think we could figure out the cosine of pi over 16? Yeah, I think so. We would do it by using the half angle identity again. Cool. So doing that, so here's the angle in orange that I would pick out. This will be plus or minus the square root of 1 plus cosine of pi over 8 all that divided by 2. By 2 lines above, what's the cosine of pi over 8 the same as? This? Yeah, so I can replace cosine of pi over 8 with what it is. Oh, and I'm forgetting again to deal with the plus or minus sign. Here a plus. 1 plus the square root of 2 plus the square root of 2 divided by 2. Then all that, but still under the square root, divided by 2. And I had a plus here. Why plus? Because it is in quadrant 1. Where what is it in this case? Pi over 16 is in quadrant 1. That's in quadrant 1, so this is a plus. Nice. So we have an answer. There's no more trigonometry left in this problem. But that looks like something that we should probably simplify. Yes. And that 2 looks pretty bad. All right, so I don't think I can simplify the square root of 2 plus the square root of 2 at all. But I do see 1 plus a thing divided by 2. So I can add fractions as soon as I replace that 1 with 2 over 2. Let's do that and add some fractions. Equals square root 2 plus the square root of 2 plus the square root of 2, close parentheses, divide by 2, divide by 2, and all that is under a square root. So it's looking complicated, but none of those individual steps were so bad, right? What's a simplification that you see that we could do from here?
Divided by 2, maybe?
Yeah, I see it divided by 2, and then I divide by 2 again. So that's the same as division by 4. And what's the square root of 4? 2. Oh, neat. So I can do like the same stuff as I've done like 5 times today now. Giving me the cosine of pi over 16 being the square root of 2 plus the square root of 2 plus the square root of 2 divided by 2. Well, that's kind of a neat pattern that's showing up. And if I had like 3 minutes more, I would say, well, let's do it again and figure out cosine of pi over 42. If you know cosine of pi over 16, you should be able to figure out cosine of pi over 42. In fact, do people believe that that would be reasonably easy to do if we just had 5 more minutes? That's good, because that's a significant chunk of your homework right there. Nice. So, think about half-angle formulas. Maybe I'll point out. So your homework is going to have you compute a bunch of trig functions, and I think like pi over 24 is the goal. I might be misremembering. But maybe I'll also point out an extra credit that takes up a lot of pages space-wise, but I don't think it's so hard to do. Do you think you compute trig functions at every multiple of pi over 24 using some stuff like this? if you can figure out pi over 12, then you can figure out pi over 24. You can figure out pi over 24, then you can figure out 2 times pi over 24 by the half double angle identity. So I should be able to figure out 3 times pi over 24 by angle addition, 4 pi over 4 by angle addition, and so on. Nice. Alright. I hope you all have a really good weekend. Thank you. Are you still in communication with Jonah at all?
Oh yeah, still trying to talk to him, but he still hasn't responded yet. I just like, Jonah, you gotta, like when I was like, Jonah, you gotta respond because some are trying to pull like your weight a little bit, but I can't take